Students, good afternoon. Previously, I was given some videos to revise previous energy of orbits, energy of subshells. Okay, 1s has more energy or 2s has more energy or 2p, 3s. If two subshells have same n plus L value, which has more energy, which has less energy, I was given. Afterwards, half bow principle I told. Half bow principle means what? According to half bow, filling of various electrons takes place in the increasing order of their energy. Means first lower energetic subshell have to fill. After complete filling of lower energetic subshell, then we have to fill next energetic subshell. That we have to follow. And for that, I was given Moiler diagram. So Moiler diagram, few people already learned very nicely, but still if you have any doubts, please ask me. Okay, and that is very clear. If two subshells has suppose 2p and n plus L value, I told this already, n plus L value is increases, then energy increases. N means principal quantum number, L means azimuthal quantum number. So 2p has n plus L value. What is n value here? 2. So 2. L value for p 1. So it is 3. So if you use 3s, the n plus L value will be, this n value is 3 and for s the L value is 0. Do you remember? L is equals to 0. S subshell, L is equals to 1, P subshell, L is equals to 2, D subshell, L is equals to 3, F subshell. Many times I told, few people really feel bored. I'm sorry, but we have to know all these things. So for S subshell, L is 0. So 3 plus 0, it's 3. So if both have same n plus L value, we have to look at this n value I told. So who have least n value, that will have less energy. That means 2p has less energy than 3s. So 3s is more energetic. So how to fill various subshells? By knowing their maximum number of electrons. S means maximum number of electrons 2, P means 6, D means 10, F means 14, like that. So in magnetic quantum number, that also I was given, S has one dabba, one rotation, one orientation. P has 3 dabbas like this. Do you remember? So P can have maximum 6 electrons, but P will have 3 degenerating orbitals maximum. D has maximum 10 electrons and maximum degenerating orbitals are 5. 1, 2, 3, 4, 5, like that. F subshell can have maximum 14 electrons. Completely filled F subshell means 14, and how many degenerating orbitals means dabbas I told or not in our language. Those are called orientations I told or not. So F has 7. 1, 2 and 3, 4, 5 and one more like this. 1, 2, 3, 4, 5, 6, 7. 7 orientations. I told no, for F, L value is 3, so that M values are minus 3, minus 2, minus 1, 0 and plus 1 and plus 2 and plus 3. Got it everyone? So please remember all these things are very, very important. So I told you how to remember electrons also. Do you remember? Just add 4 like this. They are 4. So 4 plus 6, 10. And 10 plus 4, 14 electrons. So how to remember electrons also I was given. And how many dabbas you will have, I told. I'm not joking, because if you know how many these degenerating orbitals are present for respective subshells, if you know, then only you can write electronic configuration elaborately with unpaired electrons. So these are very, very important. If anybody not written, please write down all these things. These are very, very important. Okay, sir. So for writing, I have no need to wait. So you can have a screenshot or you can write. You can pause the video. So how to know energy? I told. As n plus L value increases, energy increases. Got it, sir? Still, if you have any doubts, feel free to ask. We are ready to explain. Okay? So now, what is a Hund's rule? according to Hund's rule, he explained about the pairing of electrons. Pairing of electrons. What explains? Pairing of explains in various degenerating orbitals, he said. Pairing of electrons takes place in various degenerating orbitals after each degenerating orbital filled with what? Filled with one electron. So pairing when takes place, suppose D subshell consists of 5 degenerating orbitals. After each degenerating orbital filling with one electron, then only pairing takes place. So what Hund said, it is very, very important, so that in a particular atom how many unpaired electrons are present, we can understand actually. So it's very important or not? Tell me for us. Very, very important. So what is Hund's rule? According to Hund's rule, the pairing of electrons in various degenerating orbitals takes place after each degenerating orbital filled with one electron. Then only pairing takes place. There are 3 rooms are there in a hotel. So 6 members, actually 4 members went. How many members went? 4 members. So 4 members, actually we cannot enter like this. This is wrong. So according to Mr. Hund, what we have to do? Each must filled with one electron like this. Means one person. 4 persons went, no? So we have to send 3 persons in each room actually. So 3 rooms are there. So 3 persons must occupy in each room. Means one person must occupy in each room. Then 4th person will pair here. So this 4th person can pair here? Yes. 4th person can pair here? Yes. But usually if 4 electrons are there, the pairing first we will do here, left side. Because all are same energetic. That's why. Okay. So that usually what the way we are following actually. Getting? So now this is about persons I was given. Now I am taking electrons are present. Who are present? Electrons. For a particular atom, in P subshell has 4 electrons. P, whatever, any P, 2P, 3P or P. I told you in previous class, P subshell means maximum 6 electrons. So this P subshell has 4 electrons now. Some 2P like this. 2P or 3P are unnecessary. P subshell has 4 electrons. Now, this P means, just before also I was given, P has how many degenerating orbital? Odd numbers I told now. S, P, D, F, 1, 3, 5, 7 like that. So S means 1, P means 3. Again I am telling the same. So please don't mind. So this P has 3 degenerating orbitals. So how to fill these 4 electrons in these 3 degenerating orbitals is a question for us. I repeat what Hund said, the pairing of electrons takes place in various degenerating orbitals after each degenerating orbital filled with 1 electron each. Okay, so this P subshell consists of 4 electrons. P means 3 degenerating orbitals are there. So in 3, how to fill 4 electrons means 1 and 2 and 3 and 4. This is correct representation according to Hund. Correct it is. Okay. So now from this you can understand there are 2 unpaired electrons. Unpaired means which are not paired. So this one and this one. How many unpaired electrons you can understand or not? Like that. Now here is there. Okay. So 4 electrons, same 2p4 given like this. They'll ask you, sir, according to Hund's rule, which is correct or which of the following is violating Hund's rule? Violating means not following. Violating. Listen these words. Which of the following representation is violating? Like this they will give diagrams in options. Which is wrong you have to observe. This one correct? Now I will say this. 1, 2, 3, 4. This is wrong. Why this is wrong? Without having one electron, I was paired here. So pairing is wrong. Same, D3 I have, D3 or D5 I have. So how to fill? Suppose this is 3D, 3D or 4D or whatever. D means same. D subshell means that filling, the degenerating orbitals, everything same. So I have D3 configuration or I have D5 configuration. How to fill D5? So D means I have 5 degenerating orbitals, as I told, that odd numbers S, P, D, F, 1, 3, 5, 7, S, P, D, F. So 5 electrons how to fill? According to Hund's rule. Pairing how happens? Correct or wrong? Absolutely wrong representation. So how to have 5 electrons? This 5 represents number of electrons. This D subshell. Are you understanding? This 3 is a principal quantum number. Means this 3D is belongs to third shell. KLM, third shell. Understanding? D subshell. 5 number of electrons. This is the way to write electronic configurations. If you understand this previously Aufbau principle, now this Hund's rule, everything, your understanding levels are more, I can say. So that you can understand periodic table easily. So that you can understand chemical bonding easily. Got it clearly? Yes. So now D5, well, what way is correct? So according to Mr. Hund's, what he said, pairing must happen after each degenerating orbital filled with 1 electron only. So 5 electrons are there. Here 5 degenerating orbitals are there. 5 numbers are there. So 5 must fill with the 5 electrons like this. So this 3D5 representation is correct and the previous one is wrong. So these are very, very important for us. Understood, sir? So what we discussed? So tomorrow means not tomorrow, after class, this I am giving 4F9. How to fill 9 electron according to Hund. We have to say, you have to send in our WhatsApp group. 4F9. F means I am giving one hint here only. There are 7 numbers. 1, 2, 3, 4, 5, 6 only I am writing every time. 7F. So how to fill 9 electrons in these 7 degenerating orbitals, you have to tell me. Okay. So here the 9 electrons, how to fill, you have to show me. So what is Hund's rule? I was given, have a screenshot, and 4F9 how to represent, you have to say. Violating means not following, like that they will ask questions, that's it. So what he said about pairing, what Aufbau said, energy of subshells. How to fill electrons, he said, filling of electrons takes place in various subshells in the increasing order of their energy. Means first lower energetic orbital we have to fill, then next energetic orbital we have to follow. We have to fill. So we have to follow increasing order of energy. So 2 rules over. Last and final. Okay. Now Paulis exclusion principle. What is this? Paulis exclusion principle. What he said first I will write. According to Mr. Paulis. According to Mr. Paulis. No, not KNOW. Okay. According to Paulis, no 2 electrons will have all 4 same quantum numbers. Means 4 quantum numbers can never be same. In a particular atom. This is very important. So no 2 electrons will have all 4 same quantum numbers. All 4 means what, sir? Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. those 4 quantum numbers can never be same for any particular 2 electrons, he said. Who said? Mr. Paulis. So what he said? According to Paulis, no 2 electrons will have all 4 same quantum numbers. For example, suppose if I taken like this, okay, and these are belongs to some 2p subshell, 2p3, and here I am writing this 2p3. So here, if you see, there is a difference. See, 3 electrons are like this, 3 like this. So 2p means n value is 2. N value is 2, and p subshell means L is equals to 1. And magnetic quantum number for this it's -1, for this it is 0, and for this it is +1. So magnetic quantum numbers are -1 and 0 and +1 here. Getting what I am saying? So here if you see that this is different, for these 3 electrons, n value is same, L value is same, because all 3 electrons belongs to second shell, all 3 electrons belongs to p subshell. So for these 3 electrons, this and this is same, but for these 3 electrons, see, magnetic quantum number is not same. Spin is same, but at least one quantum number is different now. For this electron, magnetic quantum number is -1. For this electron, magnetic quantum number is 0. For this electron, magnetic quantum number is +1. Okay. So now the same 2p3, 2p3 I written. Okay. Next I am taking 2p4 like this. Okay. So I will write like this: 1, 2, and 3, and 4. And 2p4 I am writing one more time like this: 1 and 2, 3, and 4. See, however here these 2 electrons don't have same magnetic quantum number. There belongs to 2p means principal quantum number is same, azimuthal quantum number is same, but this is upwards and this is upwards, spin quantum number is same, but this is in one degenerating orbital and this is in another degenerating orbital. So magnetic quantum numbers are different for these 2 electrons. Following? But here these 2 electrons have some difference. Okay, here what way I was given you have to see. Okay sir, clearly you must know this. Here also these 2 electrons you have a difference. So here see, this is upwards and this is downwards. So this is belongs to, these 4 electrons belongs to 2p. So n value is same. So n value is how much? 2. Here also n value is how much? 2. For both electrons. One is upwards, one is downwards. So both are belongs to second shell. So n value is 2. So these 2 electrons both are belongs to p subshell. So here L value is 1. Here L value is 1. Okay, no problem. And magnetic quantum number also same for these 2 electrons. One is upwards, one is downwards, I don't know. So for these 2 electrons, magnetic quantum number also same. Suppose -1 and -1. Following everyone? So how you are saying, sir? Because both are present in same degenerating orbital, no? So if they are present in same degenerating orbital, magnetic quantum number will be same or not? See, for this dabba -1, for this dabba 0, for this dabba +1. Like that here also, -1, 0, +1. So both paired electrons has same magnetic quantum number. But one electron upwards, that means ms is equals to +half. Here electron is downwards, that is ms is -half. See the difference what you observe? One electron upwards, one electron downwards. See, these 2 electrons which are present in this particular degenerating orbitals have same principal quantum number, same azimuthal quantum number, same magnetic quantum number, but different spin quantum number. So all 4 quantum numbers are not same. So this 2p4 representation is correct and this 2p4 representation is correct or wrong, you have to say. This 2p4 representation is wrong. So because both electrons I was represented upwards. So why are not talking about these two? These two electrons are given in different dabbas means degenerating orbitals are different. That means magnetic quantum number is different for these two. So we have no need to worry. Okay. So these two electrons is our question. These two electrons have all 4 same quantum numbers or not? That we have to check. Okay. See, both electrons are present belongs to second shell. So n value is 2. So here also n value 2. Both electrons, these two electrons belongs to p. That means L is equals to 1, L is equals to 1. Correct only. Correct? Huh? Next, magnetic quantum number also minus 1 and minus 1 because both electrons, sir, able to see what I written here? 2 electrons I written. One is like this, one is like this. Okay, so both 2 electrons are present in same dabba. Dabba means degenerating orbitals. Present in same dabba means same magnetic quantum number. Both are upside only. That means ms is plus half and here also ms is plus half. So all 4 became same. So this kind of representation is wrong. So this kind of 2p4 representation is wrong. At the time of spin quantum number itself I was told. Correct or not? We cannot represent either like this or like this while 2 electrons are present in same dabba. This concept is very, very important for us. Got it, sir? So by using all these things we have to write electronic configurations. So this representation is correct or this representation? This representation is correct and this representation is wrong. If you have any doubts, please ask me. I'll explain. Pakka. Okay? But when I will get angry means if you are not asking and after exams and all if you are asking, then I feel very bad about it. While learning itself we have to ask. Okay? Please do that. It's very, very important. So this representation is correct and this representation is correct and this representation is wrong. Why wrong understood? If both electrons are upwards, then both have same 4 quantum numbers. This and this same, this and this same, this and this same, this and this same. All 4 quantum numbers are same. Then it's very difficult or not, tell me. Yeah, it's not exist. Okay, pairing, if 2 electrons are in pairing, that means pairing happens in one degenerating orbital. If 2 electrons are present in same degenerating orbital, then principal quantum number will be same, azimuthal will be same, magnetic will be same. So what will be different? Spin will be different. If 2 electrons are present in different degenerating orbitals, principal will be same, azimuthal will be same, but different degenerating orbitals, no? So magnetic quantum numbers different. Understanding? Both are upwards, so spin will be same again. See, if 2 electrons belongs to same shell, then shell number will be same. If 2 electrons are belongs to different degenerating orbitals, m value will be different. Okay, 2 electrons belongs to different subshells. 1 electron belongs to 2s, 1 electron belongs to 2p. Then what is it? What quantum number differ? Azimuthal quantum number differ. Correct or not? Why, sir? Because here electron belongs to s, here electron belongs to p. Sir, understanding? For this, shell is same because this is 2, but subshell is different. So subshell different means what quantum number? Azimuthal quantum number is different for both electrons. One is like this, 5 electrons given like this, 1, 2, 3, 4, 5. What quantum number is different for any 2 electrons? Magnetic quantum number is different. If given like this, for these two electrons, what quantum number is different? They are belongs to same subshell, they are belongs to same shell, but they are present in same degenerating orbital. That means magnetic quantum number also same, but spin is different. One electron upwards and one electron downwards like this. Got it, sir, everyone? So in that way you can say difference in particular electronic configurations. This is new for every student, so you have to understand all these things. Okay, so we have to be very clear about all these concepts. So please try to understand all this. So very important for us. Last and final, I will give you clarity. 2p1, 3p1, two electrons I consider. What quantum number is different? First only different. Correct? Here it is belongs to n value 2, here n value 3. So for both electrons, the principal quantum number only different. If two electrons are belongs to different shells, then principal quantum number will be different. If two electrons are belongs to different, I'm considering electrons only. One electron I was considering S subshell, one electron I was considering P subshell. Here, what quantum number is different? N value 2, here also N value 2. But here L value is 0, but here L value is 1. So for these two electrons, azimuthal quantum number only different. If I consider two electrons in same subshell, suppose it is 2p2. Okay, so what quantum number is different here? Belongs to 2p. That means n value is 2, L value is 1. How I am writing easily understanding? 2p, they only said n value 2, p subshell means L equals 1, but this electron has -1 and this electron has 0 because two electrons are present in different degenerating orbitals. So magnetic quantum number will be different. So for first electron, if it is -1, and for second electron, m is some 0 like that. Understanding? Okay. If two electrons are like this, now what quantum number will differ? Like this. So for all this electron and this electron and this electron means magnetic quantum number is different. But the two electrons who are present in same degenerating orbital, if you see, magnetic quantum number also same because this electron and this electron present in same degenerating orbital, but one electron upwards and one electron downwards like this, downwards like this or like this. Now one electron upwards clockwise direction. So here spin is different or not? All three remaining same. If suppose 2p4, as I said, upwards, so it is plus half and ms is minus half. So what you understood from this? No two electrons will have all four same quantum numbers. So this is very important for us. So if you know Aufbau principle and this Hund's rule and Paulis exclusion principle and energy of subshells, then electronic configurations you only can write easily. You can write simple. If you know minimum 30 elements, you can write electronic configurations. Okay, next. How to decide stability of atom, I will tell you now after this. Okay, so which atom is more stable? So next is stability of atom. Which atom is more stable? Which atom is less stable? How to decide means you must know few configurations. One is completely filled electronic configuration and half filled electronic configurations you must know. So these completely filled and half filled electronic configurations are more stable actually. Sir, how to know, sir, atom has completely filled or incompletely filled or half filled? How to know means I told you what is the maximum number of electrons. So completely filled means S completely filled 2, P completely filled 6, D completely filled 10, F completely filled 14. Okay, G completely filled is okay 18. So 4 electrons difference I told everywhere. 4 is a difference. So if atom has completely filled configuration, S has 2 electrons, P has 6 electrons, that atom is completely stable. Okay, so after writing electronic configurations, 2 more I will explain. One is octet configuration and pseudo-octet or pseudo-inert gas configuration I will explain. But after writing electronic configurations. So completely filled electronic configuration means I think you have idea. S has 2, P has 6, D has 10, F has 14 and so on are completely filled electronic configurations. Please note down all these things. So completely electronic configurations means what you must have clarity, because few people already know because they joined early what is the chromium configuration exceptional and what is the copper configuration exceptional. They know already. So you also must know. Please, you also can understand. I am sure you will understand. Don't worry. And after once physically we started classes means again we will discuss. That is our commitment. Definitely we will explain all these things again. Like a revision, everything. Once physically classes started offline, we will definitely explain. You have no need to worry. I joined late, no need to disappoint. Everything you will understand. Okay, that's it. So now half filled electronic configuration means what? Means in this half. Of course, yes, half filled we won't say, because S has 1 electron means not stable. So for S is exceptional. S2 completely filled, that's it. For S subshell we cannot say. S subshell half filled means 1. Sir, S1 is completely filled. Oh my god, it's half filled. No sir, S1. So is it stable sir? Means no. S1 is not stable. Not stable. I repeat, for S subshell there is no half filled we consider. Okay, we won't consider half filled for S subshell. Is it clear? So completely filled we will consider for S, for P 6, for D 10, for F 14. Now what is half filled electronic configuration means? Only except this S we will consider. Means P 3 means in this half, in 6 half 3, in 10 half, so D 5 and F 7. These are half filled configurations. Half filled configurations. So half filled and completely filled configurations are more stable. So these are very. So if atom has completely filled configuration and half filled configuration is more stable. So how to know whether atom has completely filled electronic configuration, whether atom has half filled? How to know means by writing electronic configuration itself we can understand. So please revise all these things. Okay. So you will have electronic configurations in our next class. Please remember all these things. These are very important. Okay. So today you have class. So that means 21st. Okay. But on 23rd you will have only online assignment. Please remember. Again, don't ask me, sir, class is there or not, chemistry class on 23rd. Don't ask me. On 23rd you will have online assignment only. Okay, so afterwards you will have one more class on electronic configurations. Before that, if anybody want to learn electronic configurations early, please message me. I will share those videos about electronic configuration. Of course, in our next class also, me only will explain in our class. But before that, if anybody want to learn, please message me. I will give you. Okay, thank you. These are very important. Try to practice all these things, and if you have any doubts, please ask me. Thank you.